I did not know, Greg, you really made my day, because I didn't know that I was in the IMDb. Of all the awards, that I have to say is the coolest. And I've also worked a lot with Greg's wife, who's a wonderful editor, and has edited for us at Nova and at WGBH. So we're all kind of family here. Anyway, I'm really delighted to be here talking to you tonight about Nova. There's a lot to say and very limited time. So I've decided to use this talk to give you a basic introduction to the series, what we do, why we do it, and how. Nova is currently in its 39th season, which is an eternity in television. It's longer than Seinfeld, I Love Lucy, and Friends. Though General Hospital still has a few years on us, it's been running for 50 years. But longevity is a mixed blessing in television. So like Jack Benny, Nova will never reach 40. It'll just keep going on at 39 forever. Nova is the only documentary series on American television dedicated to telling important science stories week in and week out, about 49 weeks a year. We make about 20 new shows each year, and we're supported by corporate funders, foundations, individuals, PBS, and viewers like you. Thank you. Nova began in 1973, started by a visionary named Michael Ambrosino. A visionary truly in programming, not just because he hired me. At that time, broadcasting in the United States had virtually no science programs, and most broadcasters believed that science wouldn't sell. But Michael knew that the BBC had many successful science shows in its lineup, and he went to the UK for 6 months to study how. He came back convinced that the BBC experience could be repeated here, and he began Nova based on the BBC series Horizon. And as they say, the rest is history. Now, since Michael began Nova, the television industry has totally changed. The advent of cable and satellite television has created 400 channels instead of 4. But one thing has not changed. It's all about ratings. The networks have never been into science. Even the great Walter Cronkite, who loved science, was denied the opportunity to host a science show when CBS canceled his Universe series after a single season. Aside from PBS, most science coverage has been on commercial cable. Both Discovery and the National Geographic Channel have made some distinguished science programs, and they still do occasionally. But recently, they seem more engaged in a race to the bottom with reality programming focused on males 18 to 49 that shows men engaged in such manly behavior as shooting alligators in swamps, chomping down trees, driving on icy roads, searching for gold, jousting, and preparing for the end of civilization. For women, the focus is just as weird. Extreme couponing. Hoarders, including people who hoard dead animals. And my personal favorite, Toddlers and Tiaras, a series focusing on mothers who enter their young daughters in beauty pageants beginning at age 2 or 3. So you can imagine my shock one evening as I was preparing to go to dinner in Los Angeles, hearing Anderson Cooper on his CNN Ridiculous comparing Toddlers and Tiaras to Nova. Just as jaw-dropping, he said, but without all that pesky science. We all have our guilty pleasures, and I myself have been known on long cold nights back in Boston to tune into our new cultural icon, Honey Boo Boo, on TLC, formerly known as the Learning Channel. But all this showcases the distinctive nature of PBS and Nova. Alone among American broadcasters, we aim not only to be entertaining, but to be educational. Now, to do either of those alone is actually not that difficult. Research tells us that topic is what attracts viewers. So to attract high ratings, all we would really have to do is to focus on perennial favorites. For example, what I call weather porn. Natural disasters like hurricanes and tornadoes, or other topics that I refer to by the acronym TRSH, or Transparent Rating Seeking Hype. But we have an educational mission, and a commitment to genuine science content. So by way of introduction, let me play you what we call our mission reel, so you can get a sense of the scope of what we do.
In 1957, the Soviet Union beat us into space by launching a satellite known as Sputnik. And that was a wake-up call that caused the United States to boost our investment in innovation, particularly in math and science. 50 years later, our generation's Sputnik moment is back. This is our moment.
Liftoff. Apollo has arrived on board Atlantis.
Freedom Tower is going to be state-of-the-art for many, many years to come.
The biggest earthquakes are comparable to many, many thousands of nuclear bombs.
It changes the paradigm in which we work with computers. That's the vision.
It's not the genes you have, but how you use them that generates the great diversity of the animal kingdom.
This is the hardest job I've ever been on in my life.
They're a remarkable place and an opportunity to start a clean energy revolution.
Keep our fingers crossed. Let's hope. And pray. Okay. All right, we are into high electrification in the anvil.
Still getting a few precipitation particles through the instrument.
Are we alone? I think it's the grandest of all scientific questions.
This will be the most exciting adventure we've ever undertaken on Mars.
Coming up on the tree. We are in powered flight. Sky crane instruction.
Tango Delta nominal.
Unit is good. Touchdown confirmed. Proceed.
Why don't we ever see events unfold in reverse order? According to the laws of physics, this can happen.
If time isn't what we all think it is, then what is it? Did it have a beginning? Will it have an end? Where did it come from?
Every bone that came out of the ground was something brand new to science. It was really amazing.
We see the launching of the career that led to Homo sapiens.
I became deeply interested in understanding who are you in this world? What is the nature of my experience?
And this must be hydrogen.
Oh, for the Starsky and Hutch of science nerds.
I don't think you have enough aluminum foil on this oven.
We are seeing actual atoms. Isn't this a historic technological achievement?
Venus is so hot, it'll cook a 16-inch pepperoni pizza out on the windowsill in 9 seconds. We still don't know the origin of life. We wonder if life was once on Mars.
Isn't the trouble with your job the not knowing?
That is not the trouble, that is the seduction.
Payoffs have been huge. I mean, you see something nobody's ever seen before.
And the planet Earth deserves to know about it.
Look at this! Let's get moving.
I think that you'll all agree that there's never been a more important time to showcase the importance of science, technology, and engineering. You know, I never could walk and chew gum at the same time. This takes an extraordinary amount of coordination. In 2009, more than half of all U.S. patents went to foreign companies. Even with high unemployment, Manufacturing jobs returning to the U.S. for the first time in decades are going unfilled because workers lack the education to handle the technology. Last year around this time, I visited Crenshaw High School in Los Angeles and sat in on an experimental class where students were taught to create computer games as a way of engaging them in math. The task was to compute how far they had to move a stick figure a third of the way across a screen of 360 pixels. And a majority of the class, sophomores and juniors in high school, couldn't solve the problem. I saw firsthand why the World Economic Forum ranks the United States 52nd in quality of math and science education. Only 16% of students in the U.S. receive undergraduate degrees in the natural sciences or engineering, contrasting with 49% in China, 38% in South Korea, and 27% in France. In engineering alone, it's even less, with only 4% of U.S. undergraduates earning engineering degrees. Now, clearly, no television program can solve this problem, but we try to contribute in a couple of ways. First, by helping teachers. NOVA has, for some years, been the most used video resource in high school science classrooms throughout the country. NOVA Teachers, the educational section of our website, offers over 400 NOVA clips, activities, and lesson plans. And we're the #1 provider of video resources to PBS Learning Media, a library of online educational tools which is free and used by 500,000 teachers in 70% of the nation's schools. But our goal is to go beyond students, to reach the general public with a positive message about science, scientists, and the scientific process. At a time when science is under threat from both the left and the right, when the present level of funding for scientific research is in doubt, science literacy is more important than ever. And yet, more than 40% of Americans don't know how long it takes for Earth to orbit around the sun. And 48% don't believe in evolution, the foundation of all biology and medicine. Another 40% believe that humans and dinosaurs lived at the same time. Those are the people who spent too much time watching the Flintstones. So, we at NOVA consider it the core of our mission to inspire people in a way that helps them become more engaged in science, to turn them on to the pleasure of finding things out, as the late Richard Feynman put it. Our goal is to create programs that are a blend of education and entertainment, to give our viewers something smart and something fun at the same time. One viewer wrote in that NOVA is living proof that turning your brain on at the end of the day is actually more rejuvenating than turning it off. So how do we make shows that are both entertaining and educational? Priority 1, tell a good story. Our ideas come from a variety of sources: our own research team, independent producers, scientists, the mainstream press, and science. But topics don't make stories. We're looking for stories that have a natural storyline, a mystery to be solved, a mission to be accomplished, an obstacle to be overcome. Those are the ingredients of any good story, and a science story is no different. So let me show you a story that's one of my favorites. We called it Smartest Machine on Earth, and it's about IBM's recent effort to create a computer to win at Jeopardy. First, take a look at the prologue that summarizes the story.
The stage is set for a showdown the world will be watching. All eyes will be on one competitor, but he's not breaking a sweat. We're not talking nerves of steel, more like a rock-solid member of silicon.
My name is Watson.
For the first time in history, a computer will compete in the ultimate brain game.
Here's Jeopardy!
For the scientists who created Watson, the excitement and tension are palpable.
It's going to be edge of your seat. It's going to be nerve-wracking.
A 4-year odyssey comes down to this.
What really is going to happen? And you just don't know. You don't know.
There are more than reputations at stake. Some say a Watson victory could signal a new age, a revolution in artificial intelligence.
It used to be the case that intelligence was chess, right? If you can play chess, that's intelligence.
But taking on spoken language and ferocious wordplay means engaging by a whole new set of rules. It requires more than just memory to match wits with humans.
Watson! Just understanding the question is a pretty big deal.
How will Watson do it? Nova gets unique access to the making of Watson, shadowing the IBM team working around the clock, training and test driving Watson.
By Blake Edwards. Watson?
What is the Pink Panther?
And we couldn't write rules for every combination of word and phrases and context.
Refining powerful new tools of computing.
We took a huge jump with machine learning. We were like, woo!
Watson.
What is May?
Yes, you got it.
And creating a machine that can learn from its mistakes.
What is mosquito?
No.
Holiday?
No.
Artificial sweetener?
Come on now, no.
We don't understand the question. I don't understand why. We don't understand the category.
That was one of the tensest days I've ever had.
You fall flat on your face. Did I expect to get fired? No, but maybe. We came back, and the game was neck and neck.
Wordsworth said they soar, but never roam. Watson?
What is Skylark?
That is correct.
Is Watson ready to face the game's all-time champions?
This is too daunting a task for a computer.
I think we've gone from impressed to blown away.
When man takes on machine, who will win?
Watson!
What is Creed?
Yes.
Nova takes you inside the world of artificial intelligence and the quest to build a computer like none before it.
Good luck, Watson.
Smartest machine on Earth, right now, on Nova.
So hard. So that was the entertainment. Now I want to show you how we honed in on the major scientific challenge in creating this program that could win at Jeopardy.
At IBM, as Dave Ferrucci and his team tackle the Jeopardy challenge, they know that facts and rules are just the beginning.
We couldn't write rules for every combination of word and phrases and context.
They need a new system, more fluid and flexible, to navigate the twists and turns of many different kinds of Jeopardy questions. They named their system Watson, after IBM founder Thomas Watson. The electronic Watson consists of 2,800 processors. That's like 6,000 high-end home computers. Altogether, it's the size of 10 refrigerators. The team starts filling his memory banks with about 10 million documents, most downloaded from the internet. Because when Watson plays Jeopardy, he must stand alone, just like his human competitors.
All kinds of content, okay, encyclopedias, dictionaries, thesauri, books, plays, you name it.
The entire World Book Encyclopedia, Wikipedia, the Internet Movie Database, much of the New York Times archive, and the Bible are just some of Watson's resources. And to build on Watson's foundation of data and rules, the team turns to a powerful tool in the computing world. It's called machine learning.
Machine learning is just like human learning from examples. Before, people would just write rules by hand. Nowadays, it's all based on examples.
To understand how machine learning works, consider for a moment the letter A. What if you had to describe it to a computer? It's a real problem faced by the U.S. Postal Service, whose computers must decipher all kinds of addresses, printed and handwritten.
We all know what an A looks like. I know when I see it, but there's just way too many different types of A's. There are fonts where the A is just a triangle pointing up. Right? That's an A. Pretty quickly you realize there is no simple set of rules that you can write down currently for a program to determine whether a letter is an A or not.
Humans might not be able to come up with the rules that reliably identify all kinds of A's. But it turns out a computer can do it for itself, if you give it enough examples.
The way you do it is you just get an A, send it to the program, and say, that's an A. Here's another A, different one, that's an A. Here's another A, it's a different one, that's an A. Then you would give it another example, then you would give it another example, and you would do that 1,000,000 times.
The computer hunts for patterns among all those examples, and it finds them. So the next time it meets a letter A, even one it hasn't seen before. It will recognize it. This is machine learning, and it's a crucial element of Watson's programming. The team trains Watson. But here, instead of letters, the examples are tens of thousands of old Jeopardy questions, along with a cheat sheet of all the correct answers. Using machine learning, Watson will hunt for patterns between the type of question, the correct answer, and the kinds of evidence that support that answer.
Now, we do this over thousands of questions, so we come up with some way to weigh the evidence on average so that we come up with the right answer.
Now, when he's faced with a brand new question, Watson uses what he'd learned from these patterns and declares his confidence in each possible answer.
In the end, we get a list that says, here's the top answer, and we're 75% sure it's right.
Watson has now become a complex architecture of rules, raw data, and machine learning that enables him to use statistics to choose the right answer. To test out this system, the team scours the halls for IBM employees who can play Jeopardy. And everyone squeezes into a conference room.
In 1978, New Jersey monthly reporter Stephen Levy famously found this man's brain. Watson.
What is Einstein's?
Albert Einstein's, yes. The Fifth Amendment says that private property shall not be taken for public use without this. Watson.
What is just compensation?
Yes.
With this new system, Watson surges into the winner's cloud.
We took a huge jump with machine learning.
Watson with a commanding lead, 24,863.
We saw a huge jump in performance, and we were like, woo!
Up to now, appearing on the TV show has only been a dream. But Watson is performing so well, Dave Ferrucci decides it's time to call Jeopardy.
So, priority 2, as soon as I get this clip off here, priority 2, after a good story, is finding awe-inspiring visuals. Audiences want to see beautiful pictures and have a perspective they can't get anywhere else. We try to show them the world from another point of view through computer graphics and the amazing new tools of scientific visualization. So let's take a look at a segment from a recent program we made called Hunting the Elements. And in this sequence, our host, New York Times personal technology columnist David Pogue, visits a lab at Cornell University where he's stunned to learn that he can actually see the atoms in a piece of bronze that he brought with him.
So you can't see atoms with this microscope?
We can get almost all the way there, but not quite.
Okay.
And to look at atoms, we're going to need a bigger machine.
Do you have one?
We certainly do.
This huge thing? This giant room-sized thing in a shipping container? And why is it draped in shipping crate material?
Those are acoustic blankets. They are meant to absorb and reflect sound because the microscope itself is so sensitive that if you were to talk, just the pressure wave from your voice is going to give enough mechanical vibration to shake this thing around. We only have to shake things by an atom for the image to vanish.
Oh, so our little piece of bronze that we've dug out of the first machine is now the little black disc there?
Well, that's the 3mm support disc. The actual bronze chip itself is about 1/100th the thickness of a human hair. It's too small for us to see, so we have to mount it on a carrier grid so we can handle it.
Oh, so you've essentially put it on a little plate?
That's right.
Are you telling me that I can see individual atoms of my piece of bell?
That's correct.
Scientists have understood since the early 20th century that metals are crystals. That is, they have an orderly arrangement of atoms. By bombarding samples with X-rays, they were able to create shadowy images of that crystal structure. But the idea that we might one day see actual atoms was beyond imagination. If David's microscope is powerful enough, we should see regular rows of copper atoms with tin atoms packed in between. Or so the theory predicts.
The dots are atoms?
That's right. Each individual dot is an atom.
We are seeing actual atoms of my little bell piece?
The bright ones, those are the tin atoms, and the slightly darker ones, those are the copper atoms.
And isn't it kind of like a mind blower that we're actually looking at actual atoms?
I mean, isn't this a historic technological achievement?
Every time people see that for the first time, they get really excited.
To actually see atoms. Amazing.
So now I'd like to show you what we can do with computer graphics. And these were the centerpiece of our recent physics series, The Fabric of the Cosmos. So this series consisted of shows on those little topics like time, space, quantum mechanics, and the multiverse. What Brian wanted to do both in Fabric and in The Elegant Universe, our earlier series on string theory, was to create visual metaphors. The scene that I'm going to show you comes from the third show in the Fabric series called The Quantum Leap. In this scene, Brian visits the Quantum Club, a place where the rules of quantum mechanics are scaled up to the level of our big world. Now, this was a process that was extremely complicated to execute. Before shooting, the scene is planned out on hand-drawn storyboards, and I'll show you how. And the voice you'll hear is the voice of the producer, Julia Court.
We don't notice the bizarreness of the tiny quantum world in everyday life. But if you could visit a place where objects in the larger everyday world behave the way quantum particles do, you'd be in for quite a show. For example, in the quantum world, things don't like to be tied down to just one location, or just one path. One object might pass right through another. I might make my shot. But there's also a chance the ball will end up any number of places. And this may be the strangest thing of all. If people behaved like the particles inside the atom, then most of the time you wouldn't know exactly where they were. Instead, they could be almost anywhere.
Then the editor, producer, and animator worked together to create 3D computer-generated animatics as a way of planning out the actual shots that we have to shoot in the studio.
We don't notice the bizarreness of the tiny quantum world in everyday life. But if you could visit a place where objects in the larger everyday world behave the way quantum particles do, you'd be in for quite a show. And what I do here could have a direct effect somewhere else.
Finally, this involves shooting each shot over and over again with small variations in a green screen studio with Brian and with actors. Eventually, all of these different layers will be matched precisely and married together. And then the green screen will be replaced with a virtual environment and multiple animated special effects added. So we estimate that it took about 300 to 400 animator man-hours to create this finished scene. And if you think it's tedious to look at it, you cannot imagine how tedious it is to actually do it. So here comes Brian, and I have to say he was a trooper because he had to do this over and over and over again. So now I'll show you the finished scene.
We don't notice the strangeness of quantum mechanics in everyday life, but it's always there if you know where to look. You just have to change your perspective and get down to the tiniest of scales, to the level of atoms and the particles inside them. Down at the quantum level, the laws that govern this tiny realm appear completely different from the familiar laws that govern big, everyday objects. And once you catch a glimpse of them, you never look at the world in quite the same way. It's almost impossible to picture how weird things can get down at the smallest of scales. But what if you could visit a place like this, where the quantum laws were obvious, where people and objects behaved like tiny atoms and particles? You'd be in for quite a show. Here, objects do things that seem crazy. I mean, in the quantum world, there's a sense in which things don't like to be tied down to just one location, or to follow just one path. It's almost as if things were in more than one place at a time. And what I do here can have an immediate effect somewhere else, even if there's no one there. And here's one of the strangest things of all. If people behave like the particles inside the atom, then most of the time, you wouldn't know exactly where they were. Instead, they could be almost anywhere until you look for them. Hey, I'm gonna have what he's having. So, why do we believe these bizarre laws? Well, for over 75 years, we've been using them to make predictions for how atoms and particles should behave. And in experiment after experiment, the quantum laws have always been right.
It's the best theory we have. There are literally billions of pieces of confirming evidence for quantum mechanics.
It has passed so many tests of so many bizarre predictions.
There's no disagreement between quantum mechanics in any experiment that's ever been done.
The quantum laws become most obvious when you get down to tiny scales like atoms. But consider this. I'm made of atoms. So are you. So is everything else we see in the world around us. So it must be the case that these weird quantum laws are not just telling us about small things. They're telling us about reality.
So, along with story and visuals, the third key priority is selecting or creating great characters. In my experience, most scientists and engineers are passionate about their work. Many of them are natural communicators, but some are not. And when they're not, we work with them to avoid jargon and to speak in a way that everyone, not just their colleagues, can understand. One of my favorite novas ever was about a Princeton mathematician named Andrew Wiles. Andrew Wiles was far from a natural communicator. He's a shy and reserved man, and it took a lot of work and talent to get him to tell the story of his 7-year odyssey to fulfill his childhood dream of proving Fermat's last theorem. The director of this film was, fortunately, a man of enormous talent, and he needed every drop of it to keep the audience engaged in a complex story of mathematical thinking. And he did it all by drawing the audience in through the character of Andrew Wiles.
Perhaps I could best describe my experience of doing mathematics in terms of entering a dark mansion. One goes into the first room and it's dark, completely dark. One stumbles around, bumping into the furniture. And gradually you learn where each piece of furniture is. And finally, after 6 months or so, you find the light switch, you turn it on, and suddenly it's all illuminated. You can see exactly where you were. At the beginning of September, I was sitting here at this desk when suddenly, totally unexpectedly, I had this incredible revelation. It was the most important moment of my working life. Nothing I ever do again will. I'm sorry.
For 7 years, Princeton professor Andrew Wiles worked in complete secrecy, struggling to solve the world's greatest mathematical problem. This obsession, which began when he was a child, would later bring him both fame and regret.
So I came to this, I was a 10-year-old, and one day I happened to be looking in my local public library, and I found a book on math, and it told a bit about the history of this problem, that someone had resolved this problem 300 years ago. But no one had ever seen the proof. No one knew if there was a proof. And people ever since had looked for the proof. And here was a problem that I, a 10-year-old, could understand, that none of the great mathematicians in the past had been able to resolve. And from that moment, of course, I just tried to solve it myself. Such a beautiful problem. This problem was Fermat's last theorem.
So, as many of you know, I spent 3 months here last year at this time as journalist in residence. It was really an amazing experience to be here day after day, soaking in the excitement of this place and learning more about the concerns and interests of physicists. Ideas for 2 novas took root here. We're working on a program on the Higgs boson and planning one on black holes. Now, one thing that I did when I got here was try to open our program-making process to the scientists. And I asked them to help me evaluate the rough cut for a 2-hour program called Earth from Space. This program was designed to show how information from satellites gives us a whole new view of our planet. One that links the oceans, the atmosphere, the land, and life into a huge, dynamic, interconnected whole. It's a big idea, but the film was a mess, and the scientists dug into it with relish. After almost a year of work, we finally broadcast the show in February, and it not only rated with the audience, it inspired hundreds of appreciative comments on our Facebook page and from scientists all over the country. So I'd like to show you one of my favorite parts, which so clearly shows how dust blown in from the Sahara Desert promotes life in the Amazon half a world away.
The journey begins here, on the ancient lakebed in the Sahara. The wind sweeps up a few flakes of diatomite into the air. The flakes fracture into a fine powder and are carried off by the wind. A dust storm builds. "22,000 miles above, the European weather satellite Meteosat 8 looks down from its geostationary orbit. It records a daily pulse of dust rising off the Bodele Depression. Here, it's visible as a whitish dust cloud lifting from the desert with clockwork regularity at noon each day.
Although the individual particles of dust are minute, they're like hundredths or thousandths of a millimeter in diameter, there are such vast clouds of this dust that you can see it on satellite images.
The dust cloud is over 100 stories high and 200 miles wide. From here, it will head west on an epic journey.
We're taking literally thousands of tons of this dust, which is containing phosphate, and exporting that from the Bodele. The wind is carrying it out across the Atlantic to fertilize the Amazon.
Rain falls incessantly throughout the Amazon's wet season, delivering thousands of tons of phosphate into the forest below. It passes into the soil and the roots of the trees, nourishing the rainforest. The effect of all this natural fertilizer can be seen clearly from orbit.
All of the globes that you saw there were animated, but the data came from actual satellite data. Now, speed has never been our thing at NOVA. We're telling complicated science stories, and it takes a long time to get them right. But lately, when news breaks and science is involved, we've jumped on the case more quickly than we ever thought we could. We covered the rescue of the Chilean miners and the technology involved in that, the tsunami and earthquake in Japan, Hurricane Sandy in 3 weeks last fall, and most recently the explosion of a meteor over the Russian town of Chelyabinsk. In that case, we asked physicist Mark Boslow of Sandia National Labs to come with us to Russia with 1 day's notice. And he was able there to collect data, to model the meteor explosion, and with his colleague Peter Brown of Western Ontario University, to figure out the size of the meteor and the angle with which it struck the Earth's atmosphere. Now, covering science under news-gathering conditions is a huge challenge, and I certainly would not want to do it every week or even every month. But on occasion, catching public interest when it's high and telling the science stories behind the news is a rush. And I'm really glad our team is developing this new capability. So here's a quick look at the meteor story.
It came from outer space, searing the sky over a densely populated Russian city.
I went to the window and I looked outside and I just saw this giant streak across the sky.
It was so bright, it was blinding, and I had to look down.
A white-hot fireball as big as a building, weighing 10,000 tons, headed for Earth.
People had no idea what was about to hit.
My first reaction was, this is the big one. Probably something bigger than we ever expected to see in our lifetimes.
This is a once-in-a-century event.
It's the biggest recorded meteor strike since 1908, when another monster from space flattened 800 square miles of Siberian forest. But unlike that blast, which took place in an isolated wilderness, this meteor is witnessed by a multitude of stunned onlookers. Captured in frightening detail by dozens of digital cameras.
We've got a unique event taking place in an environment in which people have filmed it extensively. It's absolutely incredible.
It's going to be a huge bounty to science.
Now the race is on to find out what really happened through unprecedented video evidence, dramatic eyewitness accounts.
I had never seen anything like that before in my life.
And new clues on the ground.
Crust formed, exploded in the atmosphere. Here I am holding it in my hand.
Scientists piece together the complete story of the blast heard round the world and the even bigger disaster that could have been.
When something going that fast slams into even really thin air, there's tremendous forces on it.
The atomic bomb dropped on Hiroshima was about 15 to 20,000 tons of TNT. This is about 20 to 30 times that event.
Will we be this lucky again? Is there any way to predict the next meteor strike?
So I just want to tell you that almost all of the shows that I've excerpted here today are online at NOVA's website, which is pbs.org/NOVA, along with articles, interactives, and commentary. We also have a new physics blog called The Nature of Reality that I hope you'll check out. But of course, if you'd like to see a program and you missed it, you can just ask Sarah and she'll contact me and I'll send it to you. So what's in NOVA's future? Well, using that formula of storytelling, visuals, and characters that I've described, we will continue to strive to tell the great stories of science with quality and distinction. Along with our loyal asset, NOVA's greatest asset, along with our loyal audience, NOVA's greatest asset is its relationship with the scientific community. like the people here at KITP. They give us their time, and they lend us credibility, and our job is to get the science right and to help them share their ideas with the public. It's a wonderful partnership that has endured for many decades, and I'm grateful to be in a position to carry on the tradition. I want to thank you all for your interest in NOVA, and I'd be happy to answer any questions that you have.
So I'd like to open up floor for questions, comments, or suggestions. Yes, sir?
I understand that Watson had a proclivity for using obscenities when it was first started. Can you tell any anecdotes about that?
Well,
you mean the computer program?
I can't tell you about the computer program because I actually never heard that it did. But I can tell you about the scientists and engineers that worked on it, and they sounded like sailors when they. I mean, these guys worked for 4 years, and they were really working day and night. And once, of course, they had decided that they were actually going on Jeopardy, and they were committed to doing it, the pressure was enormous because they really were afraid that they would fall in their face. And it was actually only the point at which they got machine learning to really work that they got more confident.
Yeah, I understand that they could never figure out how Watson decided the amount of money to bet on Double Jeopardy as well, because he came up with apparently random numbers. I don't know if they ever solved that, do you know?
I heard that too. That wasn't part of our program, so I don't know that much about it. But I heard it too, and I think they really needed to focus on getting Watson to answer the questions. And of course, the hardest thing about Jeopardy questions, if you listen to them, is actually understanding the question and kind of figuring out what they want as an answer. I mean, I know I'm a Jeopardy watcher, and as you watch it more and more, you get more adept. And that was actually true with Watson. As they fed it more and more and more questions, it figured out the patterns. But as far as betting, not sure.
Yes,
yes, could you tell us something about the intended target audience of the program and who the audience actually turns out to be?
Right. Well, you know, it's very interesting because in commercial television, they all aim at a demographic, not the networks, but commercial cable, which is kind of what I know most about because they have been our competition in the past. And they're all looking for a fairly narrow demographic of males 18 to 49. And that's because that's the audience that their advertisers prize. So, and that's how their advertising rates are valued. And that's why you'll see on National Geographic and Discovery, you will see so many male-oriented programs, is because that's how they set their advertising rates. We're kind of different in the sense that we really are aiming at everyone. We don't get everyone, but we're aiming at everyone. So when we set to make a program, our programs are not intended for children. A lot of teenagers watch our programs with their parents, and it's very valuable to us and to the National Science Foundation, which funds us for certain series, that often these shows are watched by families together. NSF likes that a lot because the main influence on children's choice of careers, although sometimes I think it's hard to believe, is their parents. So NSF feels that if families are watching these together, it may steer more kids into science and engineering. So our main audience are adult males from about 35 to 65. But we also have a lot of females, and it's about different shows are different, have different proportions, but it's about 56% male and the rest female. So that's not, but we don't think when we make these shows, okay, all we care about is guys watching. So it is a male-skewed audience. It is older skewed. But there are differences in the people, and there are people from all age ranges and all ethnic groups included in the audience, not just the NOVA audience, but the PBS audience. Part of it is PBS is free, and it's available in 95% of American households, which cable is not.
Yeah, question.
Yeah, I've noticed quite a difference in the tone and interest for me between Nova and Nova Science Now. Mm-hmm. Is there a difference audience?
The Nova Science Now audience is younger. And the idea behind Nova Science Now is our magazine spin-off. Unlike Nova, which has been on the air for almost 40 years, Nova Science Now has only had 6 seasons. And whether it will ever have another season, I don't know, because raising money for it is just enormously difficult. And it really all depends on NSF. And as you know, NSF has really been cut, and they've really cut the contribution that they give from media. I think they're only funding 3 media projects this year. So we have an application in. Whether we get it, I hope we do, but those are very difficult odds. Nova Science Now is intended to be lighter. We call it Nova Light sometimes. It's not intended to be mindless. It does have solid science in it, and we have a very high standard for the science that we explore. But it's generally funnier. Neil deGrasse Tyson was our host for several seasons. Now David Pogue is the host. It's lighter, it's funnier, they joke around a lot, they engage with the scientists in conversation more, so it is a different tone of the program. And I'll tell you, we had a funny experience because we put it in. At first, we make 20 new shows a year, but we're on the air every year, 48 or 49 weeks. And so we have a lot of repeats. I just hate these repeats. It just, I don't mind if shows are repeated once, but after the second time, I really don't like it. I think we should be doing new episodes, and so does PBS. It's just really a matter of money. So when we started Nova Science Now, I had what I thought was really kind of a brilliant idea. I said, let's stick in these new shows in the Nova time slot. Isn't that great? Instead of having these tired old repeats, we'll do this. The audience hated it. They went insane. You had never seen letters and emails. They went crazy. They hated it. We pulled it right out. We put it in a different time slot. The two audiences are not, there are some people who watch them, but the overlap is actually rather small.
Was there a question now? Yes.
Do your shows go into schools, or is it strictly what a child would see if their parents were watching at home?
Nova is the most used video resource, in high schools nationwide. So teachers are very aware. We have a newsletter for teachers. Teachers are very aware of Nova programs. So they use them in 2 ways. First of all, we all know teachers are just under enormous pressure to just cram in tons of content in their classes. So showing a 52-minute film in a high school class is a non-starter. But teachers often assign them for homework. They also we have short video clips. We have more than 400 of them that teachers can use, and they're all indexed and cataloged in PBS Learning Media. So, for example, if a teacher is teaching geology and they're on a unit of volcanoes, they can go and see what our collection is on volcanoes. There are essays, there are interactives, there are activities for the kids. So they're very, very widely used. Plus, we now have a new activity for teens called Nova Labs. We did some focus testing. We asked kids, what would you like that's missing for you on the internet? We actually thought they'd say nothing, because there's tons of science on this Worldwide Telescope and a lot of stuff. They actually said to us, there's a lot of big data on the internet, but we can't use it. It's just not formatted easily for us to use. And we want to participate in science. We actually want to get data and have problems, research problems that we can do, and contact scientists about it. So we've created this activity called Nova Labs. I think we have about 6 of them now on all different topics, from energy to clouds to the sun to cybersecurity. We're now doing one based on the RNA Eterna game, which is very, very popular, where people actually solve protein and RNA folding problems. And the kids are really enjoying that, and teachers often assign that as extra credit. That's how teachers use it.
Alan, did you have a...
That was the question. Because we grew up with Scholastic, and when Sputnik came along, we had science 3 times a day in the school system. So I was wondering if you could replace that, the Scholastic programs that we so enjoyed, with NOVA. You answered the question. Thank you.
Yes.
So one of my big frustrations these days is the number of people who make very uninformed decisions, sort of oblivious or intentionally ignoring scientific evidence. And you talked about the fact that the majority or some significant number of people don't believe in evolution, a similar number of people don't believe in climate change, etc. So I'm wondering if, in your experience at NOVA, you have found strategies that work for appealing to that audience that whose normal bias would be to ignore or discount science and draw them in.
To answer your question, I think on climate change the answer is no, we have not found a strategy. We make programs on climate change. We made 14 of them, in fact. And they all follow the IPCC, and they're, very kind of, they're orthodox science. But nobody watches them. It's really, honestly, it's really kind of sad. Occasionally, one of the ways that we found with climate change is we followed a photographer named James Balog, and he went to the Arctic, he went to Greenland, and he is an amazing, a beautiful photographer, National Geographic photographer, and incredibly gutsy. I mean, almost reckless. And so he was in Greenland, and he was going into these moulins, these whirlpools that would go half a mile deep into the ice cap. That program actually was popular because it was a climate change program disguised as adventure exploration. Our audience loves that. These programs consistently, we've tried everything. We tried gloom and doom. Gloom and doom does not work. That does not work. That's like making shows about cancer and Alzheimer's disease. No one watches them. We still make them. We don't make them every week. We make them when important things happen. No one watches them. But no one, when you're in a mass audience, means instead of getting an audience of maybe 5 or 5.5 million, you get an audience of 4 million. And then they're on the web. They're repeated. They're on the web. So actually millions of people watch them. So they still are really seen. It's discouraging. Now, interestingly, on evolution, we used to just not acknowledge the evolution controversy. We really didn't. We thought that it was kind of undignified to even admit the controversy. And so we just never did it because there's not two sides to that issue. There's nothing right about creationism as a scientific theory. I mean, there's nothing right about it. So you can't have a balanced program. It would be impossible. My mind changed when a landmark court case in Dover, Pennsylvania in 2005 actually ruled that the school committee could not force teachers to teach another cockamamie anti-evolution theory called intelligent design. And we decided to make a film about that because the trial itself was like a primer in evolution. It was so beautiful. It explained everything with top scientists. And so we actually made a film. We made a 2-hour film about that. And it actually did very well. I was kind of amazed. We dramatized the court case. We had to go through thousands of pages of testimony, cutting things down. We had lawyers all over us parsing every single little word. And a teacher, I often get letters from teachers. So I got a letter from a professor at Ohio State who's an entomologist, and she teaches the freshman biology class. And she sent me a letter that she got from one of her older students, who was a 31-year-old Marine who was going to college and taking her course. And he had been raised in a very firm evangelical Christian home. He said, I never believed that I never believed that evolution could be true, and yet when I saw your show, a light went off, and I really understood that there was no contradiction between religion and science. And it was just a great moment, I have to say. I wish I'd get more. But people watch that show. But we don't have a secret formula. I wish we could find one, especially on climate change.
Yes,
you must be juggling numerous projects in various stages of preparation throughout the year. It boggles the mind. If it's a small team you're working with, is it a big team? How do you manage going from one stage of one project to another, all over the world, getting film? I can't imagine how big the group is that makes all this happen and makes it done so well.
Sometimes we get Excedrin headaches. We do tend to sometimes get kind of disorganized. Actually, we have a fairly small team in Boston at WGBH. It's myself, and then I have 2 senior producers, and we pretty much manage the kind of creative control and the editorial control of these films. Now, they're made, but every film has a producer. We don't have any producers employed at WGBH. We used to do that. Now we use freelance producers because it's just too expensive. So our producers are freelancers. Our camera people are freelancers. Sound. We have a couple of associate producers on the staff. But mostly, when a film, occasionally with very difficult and tricky films, we bring them in-house if they need, like the teacher, you have to move your desk up to be near the teacher. Instead, you're bringing your edit equipment into our screening room. So, but it's, and so, you know, we have a lot of business people, finance people. In fact, that's the fastest growing area. We're being dwarfed by it. Compliance is the new thing with federal contracts. What a nightmare. So, I mean, you know, we somehow manage it. We have a great team. People from NOVA are a great team, and they love what they do, and they work long hours, and they're pretty happy doing it. So it's amazing what you can get done when you actually like doing what you're doing. Yes.
I think you said there were a couple of shows based on your visit here. Mm-hmm. I'd just like to hear more about them.
Well, I can't tell you too much because the black hole show we haven't actually started, but we are really thinking about it. It'll be a 2-hour. You know, here's the thing: for the Fabric of the Cosmos, it took 5 years to get the money for it and 4 years to make it. So, I mean, that's a very tough, challenging project, and it was a very expensive project because you could see all the steps in the graphics. And in the last month, we faced a huge pressure to finish the series and to get it on the air. And the last month, we all went to Bethesda, Maryland, and lived basically in the animators' quarters because it was just so difficult to get all that animation done. But so black holes, I think that it will be, you know, it will start with kind of simple things in the geography of black holes, the black hole in the center of the Milky Way galaxy, and it will go up to some of the things I observed here about black holes and information, and so I think, so we're just kind of developing it now. What we have to do when we think of a project, we write proposals. And this proposal will go to the Sloan Foundation, which is a great supporter of science literacy. It takes a long time and a lot of money to write these proposals, and we get them out all over the place. Honestly, the problem is not making the shows. The problem is getting the financial support for them. And that is what's tedious. But, I mean, that's the way it is.
So I'm curious whether, given the crisis of funding in science and in general, whether there might be an interest at NOVA in doing more programming around health science illiteracy. As I'm a diabetologist, so this as an example, diabetes being an epidemic and worldwide, I think there would be funding available to do programs not just about everything. There's just an explosion of science that's going on in understanding the obesity epidemic and diabetes begetting diabetes in essence.
So are you suggesting NIH as a possible?
No, I don't think NIH, but Robert Wood Johnson Foundation and other healthcare foundations that are interested in public health.
I think it's a great idea, but the foundations just won't support media. Robert Wood Johnson, we worked with them once on a program about smoking years ago, and the effort to create the artificial cigarette. And we haven't gotten support from them since. NIH basically doesn't support media, although we actually made a program on personalized medicine called Cracking Your Genetic Code, which was, I thought it was a very good program. Our audience does not take medical programs. That's not a reason why we shouldn't do them. And I agree with you. I came to, the job I had before I came to NOVA was working for Tim Johnson at ABC. So I really like making medical programs. And interestingly, one of the programs I made with Tim was called Someone I Once Knew, and it was on Alzheimer's disease. This is how I date myself. And that was just at the point when scientists were beginning to understand that Alzheimer's disease was a pathological condition and not just a condition of inevitable condition of old age. Now we're doing another program on Alzheimer's. And one reason I'm here is because there's an Alzheimer's conference here that I'm attending with Ken Kosick, and that was something that I learned about when I was here. This very, very interesting prevention trial that's taking place in Columbia, and I'm very excited about that. So I agree with you. I think PBS should have a medical series, not necessarily NOVA, but should have one. I think that's kind of information that's critically important to people. So I hope they will.
I was under the impression that you shared some of your costs with the BBC. Was that not the case anymore?
We started off, and we were the little sister of Horizon, and it was kind of like the reverse revolution. And coming from Boston, I was particularly sensitive to it. It's like the Boston Tea Party, and all the producers came from Horizon and from the BBC, and they taught us. And you know, the British have an amazing science documentary tradition that we don't have in this country. And one of my goals as executive producer has really been to develop this talent. There is a tiny, tiny, tiny cohort of documentary producers who can actually make shows about science. Very, very small. One of our biggest problems is when we have an idea is finding someone to produce it. And we still work a lot with British companies. Our relationship with the BBC kind of changed when the BBC did a big $500 million deal with Discovery Communications. And Discovery got first choice first option on all of their science. So we were kind of taking the leftovers. Now, because Discovery has changed so much, the leftovers are actually pretty good now. So we still do work with the BBC. Just it's not the same relationship that it was.
PBS and NOVA sell these programs for home consumption.
We do.
How long do they keep those in production? Because I've tried to get some of the older ones and they're no longer available.
Really? Well, you should just tell Sarah and she'll find out. I have them all. If you want a DVD, I run a little black market kind of thing. I say when museums call me and stuff, they want to use pieces of our program. So I say, look, if you need legal paperwork, I'll turn you over to our legal department, and they'll deal with your legal department, and good luck. You know, call me in 20 years when it happens. If you don't need any paperwork, I could just send you a DVD, use it. I believe our program should be available and accessible to anybody who wants to see them. So,
the new initiative from Obama on the brain, it seems to me that part of that has to be public dissemination of discovery and new research. Is there a role for NOVA in there?
Well, I mean, I hope so, because I'm looking for money for this Alzheimer's program. And I mean, the the research is so great, and because of the advancements in scanning and biomarkers, they actually will be able to get results probably in 3 or 4 years. So my hope is to be able to do a show now and then a show when there are results. But I've heard a lot of scientists complaining about this and saying that this new initiative is really a PR scam, that none of this, or very little of it, is actually new money. So I don't know. I haven't done a lot of research in it, but that's just what I'm hearing.
Okay, well, I think it's getting late, so let's thank Paula for...
Thank you. You're a great audience.